Good morning. So this is our fourth lecture for computable general equilibrium models. And today we're going to work on the welfare properties of the Walrasian equilibrium. Basically, we're going to discuss the first and second fundamental theorems of welfare economics. Let me share my screen now. Okay. So what you see here is a Edgeworth box economy. So I want to express some stuff by using the two-person case. Okay, then we're gonna discuss other stuff. So first, imagine that this is the point of initial endowments. Okay, so if this is consumer 2, this is consumer 1. Maybe I can use different colors. Okay, so the black one is the first consumer, the blue one is the second consumer. Okay, so in this direction, the utility of the second consumer increases. In this direction, the utility of the, so this is U1, this is U2, let's say. Okay, so as you see, there are indifference curves. Now, if preferences satisfy certain properties, then we can first construct what we call the Pareto set. Okay, in some texts, this is called the contract curve. Okay, so the terminology differs from resource to resource, but this is my preferred terminology. Okay, now what do we see here? If there is no exchange, right? If there is no exchange, the first consumer obtains this utility, right? Let's denote it by U1 bar. Okay, and the second consumer obtains this utility, right? U bar 2, right? Because if there's no exchange, they are here. They have this amount of goods, right? So the first consumer has this from the first good, and this from the second good. The other has this for the first one, and this for the second one. Okay, but we also see something else. In the Pareto set, the slopes are identical, right? The slopes are equal. So across the Pareto set, the marginal rates of substitution are basically equal, right? Now the question is this: obviously, the first consumer would prefer, right, any other allocation that gives a utility larger than or equal to U bar 1, right? Which means if you go this direction from this point, right, that's good for the first consumer. Now the same is true for the second consumer. The second consumer would prefer any other allocation that gives a utility level larger than or equal to U2 bar, right? So in that sense, this direction is good for that. So in other words, while the entire set of points across the Pareto set are negotiable, right? And because, I mean, why are these things negotiable? Because they can agree on the same price ratio, right? So So they can agree on the same price ratio. For instance, here you have that, right? Here you have that. Here you have that. You see? Across all these points along the Pareto set, they can agree on the same set of prices. The problem is that the first consumer, H1, would not prefer this site, right? If you look at this carefully, the first consumer is already at U bar 1, right? So this part is not welfare improving for the first consumer. Similarly, allocations on this part of the Pareto set are not welfare improving for the second consumer. So what happens then? Well, there is this set of allocations that are on the Pareto set that are welfare improving for both parties. Okay? So this is called core. All right? Because in the core, right? In the core, U1 is greater than U bar 1 and U2 is greater than U2 bar. Okay? So these are not just on the Pareto set, but in the meantime, the allocations on the Pareto set have the same price vector and welfare improving for both parties. Okay? Then, of course, we have a particular let's say this one, okay? A particular, let me choose a different color. Let's say gray. Okay, so this will be Walrasian equilibrium. Now here, what do I have? I have that, okay, and I have I have that. All right, as you see here, at this point, they agree on a new set of prices. This is maximized. And where's blue one? This is maximized. Okay. So Walrasian equilibrium will be on the core, and the core will be on the Pareto set. Okay. Again, in Pareto set, we require the same P1, P2 ratios, right? Because they must agree on the prices. So remember that remember the idea. The ratio of marginal utilities, prices, right? So this is the Pareto set. But then in the core, we require utilities are improving. Relative to what? Relative to the case of no exchange. Then in Walrasian equilibrium, both must be correct, right? So there is a set of P1 star, P2 star, the price ratio, and then we have optimal consumption levels. All right? That's the idea. So you will always find the initial endowment vector, okay? After you find the initial endowment vector, you're gonna find the welfare improving allocations for both parties, okay? Then you're gonna find a particular price vector, okay, that becomes the Walrasian equilibrium. All right? So that's the idea of the Edgeworth box. Okay. Now we're gonna discuss the fundamental theorems of welfare economics, right? So the first fundamental theorem of welfare economics, and second fundamental theorem of welfare economics. Okay. Now, very simply, we have this, the first fundamental theorem of welfare economics. Every Walrasian equilibrium is Pareto efficient. Okay, and the second fundamental theorem of welfare economics says any Pareto efficient allocation can be implemented as a Walrasian equilibrium under appropriate initial redistribution schemes. Okay, so these are the informal statements of the fundamental theorems. Okay, so if I go open a new page, all right, so let's go back to the Edgeworth box. Okay, now I know there is this initial endowment vector, right? Now I have the first consumer. The first consumer have a utility level at this initial endowment, right? Then we have the second consumer. So the second consumer will also have a utility level with at this initial endowment, right? Now, obviously, the core is somewhere here, right? This is the core. Now, I allow these people, these consumers, to freely exchange goods and services, okay? But in the meantime, what do I also require? I also require that, since this is an endowment economy, right? Their income is going to originate from this endowment, okay? So the price vector in equilibrium okay. So the price vector should intersect with the initial endowment points, okay? Here, this is initial endowment, because you should remember, they're gonna sell, right? Their income is P1, E11, let's say, plus P2, E21, right? So this is the income of the first consumer, for instance, right? So the equilibrium price vector should intersect with that, but in the meantime, it should be on the core. And by being on the core, I of course require it is to be welfare improving, right? So I have that, and I have that, right? Now, why is that Pareto efficient? Now let's zoom to the core, okay? Let's zoom to the core. So I have, okay, I have this, right? So this was the core. And then there is this point where red looks like this, and the second consumer has this, all right? This becoming the Lavoisier equilibrium, okay? So what is going on here? Obviously, let's say this is the endpoint of the core, right? Obviously, relative to the no exchange, they both prefer all of these allocations along the core, right? But if you want to go this direction, this decreases the welfare of the first consumer. If you go this direction, this decreases the welfare of the second consumer, okay? In that sense, the Lavoisier equilibrium is Pareto efficient. So this is the first fundamental theorem, right? Because again, be careful. Relative to the exchange, relative to the case of no exchange, they prefer any allocation on the core. But if they're gonna exchange, if they're gonna go into exchange, then this particular price ratio, okay, is Pareto efficient, because if you go this direction, that decreases the welfare of the first consumer. If you go this direction, that decreases the welfare of the second consumer. So you cannot increase one person's welfare without decreasing the others. Okay? In that sense, this Warren equilibrium is Pareto efficient. Okay? Was that clear enough? It is.
Yes.
It is entirely about some preconditions. I'm going to discuss them right now, but most specifically, it is about the shape of preferences. Right? Preferences are convex. By this I mean the set here defined for instance, for the first consumer, this set, sometimes called the upper contour set, is a convex set, right? This is convex. Similarly, this set is also convex. In fact, I mean, as you see, remember what does it mean? So you choose 2 points, and any linear combination of these 2 points are still in the set, right? So this is the convex set. All right. But what are the other preconditions? First, no public goods. Second, no externalities. Third, no asymmetric information. And finally, no missing markets. So if you satisfy these, and if preferences are well defined and well behaved, then you have the first fundamental theorem of welfare economics. Okay. Some people, argue that this is basically invisible hand. Okay, you let the market be, you let people behave by their self-interest and freely exchange goods and services, then you got the Pareto efficiency. Okay. All right. Now, let's discuss the second fundamental theorem. Second fundamental theorem of welfare economics. Once again, let's imagine an Edgeworth box. Okay, and once again, you have the initial endowment vector. Okay, so you have the let's say you have the first consumer here, you have the second consumer here. So second consumers so let me just show you this first. So let's say this is your Warren equilibrium. Okay. So now you have the Warren equilibrium allocation. All right. So have that, and you have that, right? Obviously, for the initial endowments, you have something like that. And for the blue one, you have something like that. Oops. Okay. So this is just the core. All right. Now, the idea is that if you start here, right? If you start here, you go to this equilibrium, right? Because it is already there. So there's a price ratio. Okay. So this becomes your Lavoisier equilibrium. Now imagine that you would prefer another allocation. Okay, you would prefer not that allocation, but let's say an allocation that is, let's say here. Okay. Let's say you prefer that one. Now, how do you make the economy to go to this equilibrium instead of this one, right? Let's say this is E0, and you want the economy to go to E1. The idea is this. You're gonna change the initial endowment vector by taxes and transfers. All right? So you would imagine okay, you would imagine this, and then you have oops. So let's first draw it. So you have this, obviously, right? So this is Lavoisier equilibrium 0. And you want Lavoisier equilibrium 1. Okay, E1. So how do you go to that point? Well, first of all, this must be an equilibrium, right? So you have something like that. Obviously, you have something like that, right? But then you also want the initial endowment vector to be, for instance, here. Okay? So you, oops. So you're gonna tax and use the transfers as well to move the economy here initially, right? Then you know if you move the economy here, the initial endowments, what happens? Well, for the blue one, you have something like this. This is for the second consumer. For the first consumer, you have something like this. Okay? So what happens? Again, now there is a new core. Okay? There is a new core. And in this new core, there is a new Lavoisier equilibrium. But now this Lavoisier equilibrium is also Pareto efficient by the first fundamental theorem of welfare economics. But in the meantime, this is what I prefer as the policymaker. Okay? So that's the idea. If I want to choose among two Walrasian equilibria, one without redistribution and one with redistribution. So this is without redistribution. Without initial redistribution. And this is with initial redistribution. So with initial redistribution, I again let the market behave after the redistribution act, after policy, after the change of law. Then the economy again finds the Walrasian equilibrium under competitive conditions. Okay? So let me stop here before the break and discuss these issues if you want to.
Can I ask something?
Of course.
Are the Walrasian equilibrium lines parallel?
No, not necessarily. No.
Okay.
They don't have to be parallels. The only thing is that for it to be an equilibrium, of course, it has to be tangent to both indifference curves, right? Indifference curve for the first consumer and indifference curve for the second consumer. But they don't have to be parallel. So you see, so the first one tells you that let the market be under certain conditions without externalities, without public goods, without asymmetric information, without missing markets. People freely exchange for their self-interest, but their self-interest leads to a Pareto efficient outcome. Pareto efficient in the sense that you cannot increase one person's welfare without decreasing the others. Okay? Now the second one tells you, all right, but I would still prefer one Pareto efficient equilibrium to another. Let's say in one of the Pareto efficient equilibria, there is too much environmental degradation, there's too much child labor, there's too much inequality, etc. So as a policymaker or as the society, I would still prefer to go to another Walrasian equilibrium. But in the meantime, I don't want to I don't want to distort the market behavior too much. I don't want to shut down the markets. I don't want to establish a socialist revolution. Okay? I don't want my economy centrally planned. I still want people to have their ownership rights, their contract rights, their entrepreneurship rights. But I want to lead the economy to another equilibrium. To do this, I'm going to use initial redistribution policies, initial changes in some of the economic laws, in some of the economic institutions. Then again, I will let the market behave so I can implement a Pareto efficient equilibrium as a competitive Walrasian outcome. Okay, that's the second one. So it is very much about real world economy, as you see, right? Because it's all about politics if you think about it. So these theorems not only tell us that market economy, free market is good for everybody, but it also says, they also say you can use redistribution policies to choose from different equilibria. Okay, so now I have less than a minute. So let's meet at 10:45 because it will take some time for conversion. Let's meet 10:45 for the last session. Okay.
Okay.
All right.